All right, hello everyone, this is Mr. Coach. I'm going to go over Chapter 3 test problems. First off, identify the domain and relative extrema. Well, the domain comes from this part of the function. You cannot take the natural log of a negative number, because if you try to natural log negative 3, for example, it is not defined, right? You cannot find anything with base e that will go to anything that is negative here. You cannot take the natural log of something here. So this domain has to be positive numbers. So when I start my graph here, I'm going from 0 to infinity. Well, you can find the relative max at, or minimum at 1, and put this back into the equation and get 1/3. The estimation here, linear approximation. I have this function. Here's the slope at this point. I have a slope of 1/14. I can write this equation here. And again, this comes from y minus y1 equals slope x minus x1. All I did was put this y1 over here. Here's my x1, my x, or y1. And if I do this, I get an approximation. And if I use this, I know the approximation of the square root of 52. If I plug in 52 here, I get 7.214. Well, if I were to do the real square root of 52, I get about 7.21. So that's how I find the percent error on this. And again, this is extremely close. Using this tangent line in this particular problem got me an answer that was very close. Solve this, take the derivative here. I distribute it, then did the product rule, cancels off, and then I'm in a situation again where I have two opportunities to get a 0. This could be 0 or this could be 0. E to the x could be 0. Well, to solve that equation, right, I bring the natural log, I bring the e down. If you want to see the steps for this, natural log of both sides gives me, allows this to come down. Natural log of e is 1, so x is equal to the natural log of 0. Well, natural log of 0 cannot be done. You cannot put an e there and raise it to a power and have it become 0. Then it goes down and up. The slope here is 1. Set that equal to the derivative. We have positive and negative, but only 2 is in this interval, so only 2 counts. On this problem down here, we have this equation. If I take the derivative, I'm here. And I get to this step, and at this step there's nothing to be done until I use this double angle formula that says sine of 2x is equal to sine x cosine x, and the 2 out there, I should have maybe put this 2 here for you. This is a 2, then another 2 right here. Sine of 2x becomes 2 sine cosine of x. That is a trig identity from trig class. Sine of 2x equals 2 sine cosine x. It's just a trig identity to remember. Then you can factor it, and then you have one side, two side, find the points. Don't forget to include the endpoints. All right, on number 6. Well, if I know that the second derivative is positive, that means it is concave up for the whole time. However, on problem 7, all I know is the second derivative is 0. So that means I could have a max, I could have a min, or I could have a point of inflection. And then what it depends on is what is happening in the first derivative. If they're both going down, I could have a point of inflection. If one's going down, one's going up, I could have a relative minimum. But I need to do this test in order to know what I have. And I don't have that information there. It cannot be determined. Maximum value here, check endpoint, critical point. Be careful, the critical point was a minimum, not a maximum. Number 9, the concentration of a chemical in the bloodstream. So if I graph this equation, there it is. And if I zoom 6, I get this weird looking graph. And I'm only interested for time greater than 0. So I'm only interested in over here. So, and it doesn't go up very high. So I'm just going to go 0 to 10, and I'm going to go -1 to 1. And there's the graph. And actually I don't need much at all, so why don't I just go to 0, and how about 0.2? And look at this graph. Let's go one more. Let's go 0.3. When you are given a shot for an injection into muscle tissue, at first the amount increases very quickly, and then the drug starts to wear off. And that's what this graph is showing. The greatest, will that be at that maximum? Second calc, let's calculate a maximum. Let's go ahead and do this one. Left side, right side, maximum, about 2.52. All right, what do you have on number 10? At the 0.5, at 0.5, you have a change in, or you have a critical point at 0.5 because the derivative is shown. Now what happens on the left side of this? All of these values are positive, meaning the slope is going up. What happens on the right side? All of these are negative. It's like you plugged in a number over here and you got a positive result. It's going up. It's like you plugged in a number over here and you got a negative result. It's going down. However, you don't have to plug in anything to the equation. You read the graph to find it. When we did this problem here, you were plugging values in to find the arrows. Here, you are reading graphs. All right, on this one, we have x times y is 48, a product, twice the sum of the first plus 3 times the second is a minimum. Take the derivative, set it equal to 0. 1 point I got was 6 root 2, but I plugged it in to find the other number, and the other number was 4 root 2. The question asked for the smaller, so it wants that number right there. Number 12, find the maximum value of a cylinder. Well, a cylinder has a volume of pi r squared times height. There's the primary, and I want the max volume, so there's my primary equation. I want this equation to be maxed. However, I have 2 variables here, but I can use this secondary equation. H plus D is 50. Solve it for H, take out the H, and now I have a single variable equation. The volume is just in terms of R. I can solve it. I end up getting R is 50/3, H is 50/3, and calculate the volume. Point of inflection. Again, do the first derivative test from -4 to 0. Do the second derivative test, -2. And what you'll see is -2 falls right here in this upward facing section. One side is down, one side is up. That's a point of inflection, because this graph is going to go up and then up some more, but the concavity is changing. On both sides of -2, one side's going up, the other side's going up, but this is concave down, that's concave up. Makes it a point of inflection. Increasing, decreasing intervals. First derivative test. Low d high minus high d low. After you simplify, you get here. The only critical point is at -3 in both sides. If you plug in values on this side, you don't have a graph to read. When you did this problem here, it was easier. You had a graph to read. You don't have a graph to read here. So you have to plug it in to do the math. You have to do it analytically, not graphically. Number 15, we have an equation. At the point 4, -1, I can find my approximate. This is the equation of the tangent line. Not going to bother simplifying it. This is the equation at this point. Here's a graph. Here's point 4. Here's the equation of the tangent line. Don't bother simplifying it. And now what we're going to do is see the difference between the graph. Let me draw a better picture of this. Here's the graph. What we're going to do now is see this difference right here. What is the difference between the actual function and this equation that I came up with? Well, if I plug 4.2 into my approximation, I get 0.4. If I plug 0.4 into the actual equation itself, I get 0.68. Do the percent error, 38% error. What does this mean? It means this This approximation is not a good one. It's 30% off. It's not that close. The difference here is extreme. Look, I went over 0.2. Remember when we were doing the worksheet, we were doing a lot of delta x's where it was 0.01, where it was extremely close. In this case, I went off by 0.2. It made a huge difference in this graph. All right, last one is a mean value theorem. The change is 3. Set the derivative equal to 3. You get to this point. How are you going to solve that? Quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Simplify it down to this. Two choices. One's going to be positive, one's going to be negative. I only want the positive one because the slope's positive here. So works like that. You can plug it in and you will have that change. Or actually, I only wanted the positive one because if I do, let's see here, 2 minus root 13 divided by 3, I'm outside of that interval. If I do plus the square root of 13 divided by 3, I'm still, whoops, typed it in wrong. 2 plus the square root of 13 divided by 3. There you go. Now you're in the interval. You want to always make sure you're in this interval. All right, hope this helps with your homework.